So now here are the different stages of the upwelling process. And let's have a look at the top panel. Top panel. It starts with an undisturbed state on the left, and where you imagine that you have two layers, and the bottom layer has nutrients in it, dissolved nutrients. Okay, for this discussion, it doesn't matter where the nutrients come from. Just imagine that there's a layer of nutrients in it. Away from the euphotic zone. The euphotic zone is here in the surface layer. You know that light intensity decreases exponentially, and it's already pretty dark at, say, 40, 50 meters. So now you get the winds blowing along the coast, and what it starts with is you get something we call a partial upwelling. So you get the Ekman transport kicks in, you have onshore Ekman transport, and you lift the interface closer to the surface. And if lasting long enough, the wind creates something we call full upwelling. Okay, so the bottom layer reaches straight to the surface, and then over time, the interface between the layers actually moves gradually away from the coast. Okay, you get a separation from the coast. And there's also an upwelling jet associated with this process. And the upwelling jet itself, it's a geostrophic flow that creates the bottom Ekman layer, actually also moves away from the coast. It turns into a frontal flow, which also moves along the coast and has the strongest speed at that distance here from the coast. In terms of what happens with the plankton bloom, with the phytoplankton production, it's also shown here at the bottom. So if you lift nutrient-enriched water into the lower layers of the euphotic zone, where you have enough light to support photosynthesis, you get actually subsurface phytoplankton. They are more pronounced the higher up you move your nutrient-rich water, and the maximum response you get if the upwelling brings the nutrients straight to the surface. Okay, this is the maximum response you get here. Okay, so satellites only show you the surface distributions, but you don't see the subsurface blooms. So you have to go out with a vessel and you measure it. There are the hidden secrets. These subsurface phytoplankton blooms are not fully understood. We don't know where they are because our knowledge is biased by the knowledge or from the knowledge of the surface distribution. That's interesting. Isn't it? Subsurface phytoplankton can be very strong, relatively strong.